Hello, my name is Lindsay Collins. In this video, I will be presenting about how Excel VBA can be integrated with Excel Solver to find a solution to a current healthcare issue. First, we need to go ahead and describe the problem that this project is going to be dealing with. This article that is up on the screen is talking about how there's not enough doctors in the healthcare system currently. According to this article, the Health Care Act has created a large number of patients, but has also at the same time reduced the number of doctors that a hospital is allowed to hire at once. So for this project, I am interested in seeing how we can schedule these doctors and according to the number of patients that come in and still minimize the cost of doctors and of moving the patients to different sections of the hospital. Now I'd like to go ahead and demonstrate the model that I've created to show this healthcare issue. Now this would be for an employee of the hospital to go in, and as an end result they're going to find out how many patients are going to go to the intensive care unit, the critical care unit, the stable care unit, and how many doctors are going to be needed for each of these areas. So first thing they would do is go in here and press to begin. They would enter their employee ID, press OK. It would display a welcome message and tell them the date. And then when they click OK, you're going to see the back of the report is going to populate with kind of the format of how the data is going to be imported. So it's going to show each of the data headings, and it's going to model that for us. And then it's going to say click OK to import today's patient data. And actually that patient data is located in an access file. So using VBA, I was able to call that data from the access file, and we're going to insert that into this spreadsheet. So they press OK. As you can see, the information has imported from Access successfully, and up here in the top of the spreadsheet, we have given a lot of the different symptoms of the patient priority scores, because we want to score these patients to know which are at higher risk and which are at lower risk. So they're ranked from 1 to 10, 1 being low risk and 10 being high risk. So you can see that history of chronic renal failure is a 9, so this is a high risk. These are all factored in, and each patient is given a priority score. These will be used later on to decide which need to go to critical care versus which need intensive care, and then finally which need stable care. So we can go ahead and move on to our solver. As you can see, the spreadsheet is set up, and we have our objectives, our variables, which are going to be the patients and the doctors. Also, our objective, as we discussed earlier, is to minimize costs. So let's go ahead and look at how we're going to assign these costs in this specific situation. So there's two kinds of costs. The first is cost of transferring patients. It costs $413 to transfer the patients from the emergency room to the critical care unit, $257 to transfer them to the intensive care unit, and finally it costs $158 to transfer them to the stable care unit. So obviously to minimize this, we're going to want to put as many people in the stable care unit as possible. Also, we have to look at the salaries of the different doctors. I got this information from salary.com, and the average of a critical care doctor was the amount shown here. I also used this then to make up salaries for the intensive and stable for the point of this project. I also decided to put it in the amount per day since we're dealing with per day cost, and this is based on a 250-day work week. So you can see the costs for each of the different doctors shown here. Now if we go back over here, we can go ahead and solve it to see what our minimum cost is going to be. Solver did find a solution, and it's going to be over here. It's located right here, and it's $77,000 per day that we're going to minimize costs. Now let's look back and go through the constraints to make sure they're all met. First, you can see the availability of each of the departments was met, because there was only allowed to be 40 in critical care, 60 in intensive, and 110 in stable, and as you can see, all of these were met. The same for the doctors. We only have a certain amount of doctors on staff, and so we have to make sure that this amount isn't exceeded. The person that is working with this spreadsheet also has the capability to change these numbers up and down. These are the patients that each doctor can handle for one. Obviously, you can see that critical care patients require a lot more attention, so doctors can only handle a few number of these patients. Down here, we're looking at the number of patients in each of the different segments. So these patients that are highlighted in red can only be seen by critical care doctors. They had high priority scores, so I think there was 27 of those that had to go to critical care. These could go to either intensive care or, of course, they could go to critical care. In stable care, down here, these patients could go to any of the different segments of the hospital. Another constraint that was met was the doctors times the patients the doctor had to equal the total number of patients. And as you can see, this does equal 200, which is the number of patients we had. So in this case, we have met all the constraints and successfully solved this problem. I've also created a pie chart so we can just visually see the different units and the population of patients that went into each. It's pretty basic. Obviously, more patients were in the stable care unit because this helped to minimize costs. Now we're going to go ahead and just look over briefly some of the VBA code that was used for this project. First, you can see here one of the user forms that was implemented into this project. If we view the code for this, we can see how clicking OK pulled the access information from that file that the patient information was in to the spreadsheet. You can see that first we opened the path, then we used SQL to select all of the different variables from the ICU data and place them in the different ranges. So you can see I wanted it to start in the fourth row down, so I said CO equals 4, put in the different columns that I wanted each different variable shown over here to fall under, and then moved to the next column every time one of those was inputted. So we can also look at our solver. We can see the different constraints that were input and the maximum, the minimum value. We can see that we didn't want the user finish to appear at the end. A few of these were recorded, such as creating the headers to the patient data and stuff like that. Those were recorded macros. You can see how the message box were displayed to welcome the employee. So that's just a few of the macro code that I used, briefly explaining just how all this came together. Thank you for watching this video, and I hope you enjoyed.